How do you organize an embedded Swift project, and what do all the files mean in Visual Studio Code or in the command line? Hey, what's up? This is Paul Solt from Super Easy Apps. I'm going to get you started on embedded Swift so that you can understand the project format. This is as I understand it. I've been playing around with it for a few weeks, maybe over a month, I guess. And I've learned a lot. I still have a lot of questions, but I have less questions than when I started, and I have a better sense of how to get started. So this is sort of a new project. It's sort of based on Apple's code, and I'm just going to take you through how this looks, how you get started with it, so that you understand the basics of working in embedded Swift. So let's get started. So first off, I've got this project open. I've got it open in VS Code. This is the LED strip. I've modified this a little bit to just have a good starting point, leveraging some of Apple's code here, and just sort of trying to show you what the project actually looks like. So there's going to be a few different components. Now I have a setup guide on how to get started with all of this stuff so that you can use Visual Studio Code. And if you want, you can check out the video for that. Down below, I'll have a link to it, or I'll have a card that's up in one of these corners that will allow you to get started. Once you've got it all set up, the next question is like, how does this project work? Like, this is totally different from Xcode development. There's not a whole lot on this, so I want to give you some pointers when you're working with it, especially in Git, understanding those types of things. So first things first, if we just look at all the files, you're going to have a main folder where we've got the code, and then I have a README in here just to have notes. There's going to be a cmakes_list.txt file. You're going to want a VS Code if you want to have code completion, and then you'll see other things that we want to hide from Git. So that's where the git ignore is really important. I've got a git ignore for this repository set up to ignore the DS store files, the build folder, a .build folder. I don't know if that exists in this or not. There's an SD config file that I actually had to remove from GitHub that I didn't realize I had accidentally committed. There's going to be a folder called manage components, and then there's going to be a dependencies lock. And we don't want any of this stuff in your Xcode project. So these are things that we want to ignore. I'm just going to make a note of that, so I can include that. And then the other thing is just sort of like looking at it. So once we compile things, we're going to get a lot more files, and it's going to be a little bit more confusing. So we're looking at it before we have all these other files. And right now it's not going to work, but that's okay. So if we take a look, how I've sort of set this up is sort of based on Apple's thing. So they've got this main folder. There's a CMake list. This is your top level project that sets a minimum version for CMake, which is the build system that we're going to be using. And then inside main, you're going to have another CMakes list, and this is going to have all of your files. Now, this is really important. I have this set up right now to include some C files as well as the Swift files. And one of the things that you're going to have to do at the bottom, you're either going to have to add files. I made it so that it's automatically adding new Swift files that are added recursively into the main folder here. But the challenge of that is if the cmakelist.txt file is not modified, if you go to build and run, it won't pick up new changes. So if I add a new file, I added like the format.swift, because there is currently a bug in this where you can't print double values. And so this is a workaround for that. In order to get this to compile, you're going to either need to add a space and save it, and you can remove the space. You just have to touch the file, or you have to manually, you can uncomment this section and comment out this one. So we could comment this out, and we could manually just list all of the new files. If you do that, it will pick up those changes when you make them. So that's your CMake build system. I'm going to go back to this one to just use that. And we've got our main file. So this is going to be our starting point. This is going to have this app main, and then it's going to have our declaration. And in here, this is just setting up a LED light strip. You don't necessarily have to run all this code. You could like take all of this code out and not use any of it and just have a print statement just to get started with embedded Swift and building it. This linker file, I don't know what this does. I haven't modified this. I think this was requesting things that, interesting. This is requesting a certain kind of layout for everything. I don't fully understand it, so I'm not going to talk about it. There is a dependency. That's what this IDF component.yaml file is for. And so this is going to have the dependency on the LED strip. So that's going to pull that in once we start our build. And then we've got a bridging header. I am pulling in a C code here. And the way I've hooked this up for some additional C code, I was trying to work around the fact that I can't print floating point numbers. So I was like, how do I get a function to print floats that I could call from Swift? Finally figured it out. There's some other magic that you have to do to get C++, so I don't know how to do that right now. I tried a few approaches and they didn't work. I think you have to create some kind of module. I couldn't get it to compile, so it's not going to be in this sample code. So, but likely you're not going to be needing to do something like this unless you need a workaround around a bug with embedded Swift implementation, because it's not full featured. It is still experimental. Not everything's working. So this is an example of how to have a C function, and I'm pulling this in. And again, this is coming in through that C makes lists. Up at the very top, I am searching for all of the C files in the source folder, which is right here. And then I'm printing them out just so that you can see them on the command line. We can see that when we go ahead and build it. And then I am including them here when I register the component. And then I'm also including the include directory, which is here, so that we have the header for the C code. And that'll get us access to that. The same thing didn't seem to work for C++, and more build flags need to be enabled for that. And you're going to have to try and figure that out if you want to. But most likely you just want to use Swift, and that's fine. So that is the overall layout. Hopefully this is helpful. Let's go ahead and see if we can build it. I'm going to build it first on the command line. So the way that we build any of this stuff is you're going to need to get the IDF. And I've got this alias defined somewhere. I couldn't find it when I was actually looking for it, which is really confusing. But it should be in my ZSH file. My ZSHRC. And when I was searching for it, I just could not find it. There it is. I don't know why I couldn't find it. It's right here. Earlier, when I was searching for it, it just wasn't appearing. So this is just getting the... it's just running this export script that allows us to work with the IDF build command. Okay, so once we do that, we can say idf.py. So that enables idf.py to be visible on the symbols and whatever build stuff we need. And I should, since this is basically like a clean checkout, I should just be able to write build. And so that's going to go ahead and build the whole setup. I'm just going to move this over a little bit. Oh, I think I deleted everything, so I do have to set the target before we build. So let's do the idf.py set target, and I'm doing ESP32 6C. So if we do that, okay, once I've totally messed this up. Let's just remove this build folder and let's try this again. So it's doing a full clean when you do a set target. That's interesting. And for some reason, it's unable to remove stuff. Maybe because I had something open in the build directory. Okay, so now we should be able to run idf.py build. This is going to build 1,000 files. It might be like 900, depending on which version of ESP IDF that you're running. I was on ESP IDF, what was it, 5.2.2, and I was trying to debug a random numbers don't work. And I tried going to the latest, which is 5.3.1. It still doesn't work there, so I have a separate blog post on how to fix that. But this seems to have built, which is great. And now we're going to see, like if I do ls-al, we're going to see we now have a build folder. We have a dependencies lock file. We have managed components. We've got the STK config and an old version of that. So what does all that look like? Well, we can look at this. A ton of stuff in here. I think this is just the previous version. Every time you build, it might just cache it just in case. Dependencies lock is what dependencies we have. We have this LED light strip that was set up from the, where was that? The IDF component that set up that. And then we've got managed components, which has downloaded a ton of stuff or installed a ton of stuff that we need for the project. So it's got a ton of files. This is our LED light strip that we've included. So it's pulled that in and all the C code related to that so that we can compile it, and some other stuff in here. So that is what the managed components is. You don't need to do anything in there. And then let's see, going up a little bit, we've got our build folder. So this gets automatically created and there's a ton of stuff in here. Now, compiler commands, this is going to be useful if you want to get code completion. I'm not going to talk about that. I have a separate post all on the beginner's guide that you can check out in the comments down below. And then we should be good to go. So now what we can do is from the command line, we can do idf.py build. It's already built. We actually don't need to build it again. We can just say flash and then monitor. And if I plug this in again to power, I've got the power disconnected so it's not blinding me. What we're going to see is the application is running on the microcontroller. And then if I pull open this, you can see it running. So I've got the microcontroller here. This is the ESP32-6C Things Plus from SparkFun. You can see the wiring setup that I have. So I'm just going off of the IO0 port as my data. And then I've got the ground connected to this. And we've got this running off of 5-volt power, which is currently a hacked USB cable. It's probably not ideal that like it sometimes doesn't work. So I might just need to switch over to the power connector, which I would recommend for actually powering something like this, since it can do that. Wire's heavier gauge than what's in this USB cable from Apple. So don't necessarily recommend that approach, but it does make it kind of convenient to get USB power without needing an extra brick. Though I wouldn't push a lot of high intensity LED color values, or you could cause this cable to warm up and be a problem. All right, so that is kind of the structure. That's it working, so you can get an idea of how this all sort of fits together. Understanding the git ignore, I think, is helpful. Understanding the project layout is helpful. And then understanding where you put your code. So most of your code is going to go in this main function. And then you can have helper files, like Apple has these helper files. And that allows you to connect to these different things. So they have some different sample code. You can start with that. I just wanted to figure out, like, what are the essential things that I need? And then how can I start modifying like the CMake lists and stuff so that it's actually giving me the code that I need. Okay, so that is pretty much all I have to demo. If you do want to do C++ code, comment down below if you ever figure something out. I don't know how to do that yet. And if I do figure it out, I might make a separate video of how to import it, because what I'd like to do is for this LED light show that I'm doing, I want to pull in some of my existing C++ code that I wrote like 10 years ago. No, longer than that. Back in 2010. So I guess 14 years ago, to help control the colors. So that's kind of my reason for wanting C++, but I might just rewrite some of that logic in Swift and not worry about it if it's a real pain to figure out. It's right now, understanding the CMakes list is like a big learning curve. I've worked with CMake before, but it's been a while and I'm rusty on everything here. So hacked it together a little bit to get some of the auto stuff. Keep in mind that if you do make file changes, you need to make sure your CMakes lists is modified so that that gets pulled in. Otherwise, you have to do a full clean and rebuild, which takes way too much time. So you're better off just adding a space, removing the space, saving it, and that should make it so that it will rebuild your CMake. So if I go ahead and do this one last thing, we can do a build flash monitor all in one line. And that should, we see it rerun CMake. And if you added a new file, it'll pull it in. Like actually, let's add a new file just for kicks. So if I wanted to add a new file, I'm going to click up on main and I'm going to say new file, and we will call this helper.swift. And in helper.swift, we're going to have a function and we'll call it do something. Okay, so that is defining a function in helper.swift. And now we want to call this from main. So we're going to go into main and we're going to just call this right before we do anything else. So we'll just say, what did I call it? Do something. So we're just going to call do something right here. And you're going to see it can't find anything in SourceKit. So it doesn't know about the symbol yet. So in order to get SourceKit to understand that, we do need to do a new build. So we're going to do idf.py build. And now we're going to have a problem because it can't find it in scope. So you'll notice that when it built, if we just scroll up a little bit, it didn't do that step for CMake. So it's failing here. So previously we saw that it was rerunning 0 of 1, rerunning CMake. It didn't do that step when we did the new build because it didn't detect a change. So it just immediately skips to this step, the next step, whatever that is. It's one of these things. So the way you get around that is you go to the inner CMakes list, which is this one. You just need to add a space anywhere. You can remove it, save it. And then if we rerun our build command, it should then execute CMake, which we see right here. And then it will pull that in, crossing our fingers. This will rebuild everything. This shouldn't take as long as doing a full clean because it's going to just do a incremental compilation. We're not going to have to build all of IDF, ESP-IDF. And now we should be able to run it. So if we do the build flash monitor just as an all-in-one command, it's going to rebuild, but everything's sort of already built. Now it's flashing, now it's installing. And then if we look, we see that it is executing. Okay. And then we see that it printed out do something. So that's how to add a new file. That's how to sort of work with the build system. Hopefully that's helpful. You're going to need to do the same type of thing. Like if you add new C files, you're going to have to update your CMake lists to include those. It is automatically going to pull them in, but again, you're going to have to trigger the CMake build system to go. And I don't know if there's a command to do that. That's something that you can figure out. So the easiest thing is just to put a space, remove it, save the file, and that should essentially touch the file so that it's dirty, and then it gets rebuilt with the build system. Okay. And then to quit, it's just going to be a control right square bracket. So just pressing this key will stop the monitor. That's the one thing. I don't know why it's not hooked up to Control C. Maybe those are used for other things when monitoring. I don't really understand how this works, or why they used that key. So there's got to be a reason. I just don't know. Okay. So thanks for watching. If you want to get access to this sample code, I've got a blog post on this setup right here and how to get started with embedded Swift. So you can go get the sample code from that blog post. And I'll have a link down below for the blog post, the sample code, and some of the stuff like the git ignore. Thanks for watching, and I'll see you in the next video.